All right, for Algebra Review Day 2, we're going to solve equations using the opposite of Pemdas, which is SAD-MEP. So we're going to try to move things using subtraction and addition first, then we use multiplication and division, and then exponents, and then parentheses. So we sort of work backwards from Pemdas. And to undo addition, we use subtraction. To undo subtraction, we use addition. And to undo multiplication, we use division, and to undo division, we use multiplication. And we usually call these opposite operations. So I'll try to enlarge this a bit. Okay, so for number 1, it says 7x minus 4 equals 3. We want to get the like terms on the same side of the equal sign. So because negative 4 and positive 3 are like terms, we want them both to be on the same side of the equal sign. So our options are to either move the 3 to the left or the negative 4 to the right. But the other thing we want to do is we want to make sure that they're separated from the 7x. So we want to keep this the constant terms on the other side of the equal sign. So I'm going to end up moving this negative 4 over to the right side of the equation. However, because this is a negative 4 currently, and I want it to disappear, because I'm moving this entire term negative 4 to the other side, I need to zero it out, meaning I need to do the opposite, which would be to add 4. So negative 4 plus 4 is 0. And then I'm going to balance the equation by also adding 4 over here. So that gives me 7x equals 3 plus 4, which is 7. Now my like terms are, combined. I've got 7x, which is separate from the 7, so they're separated. But now, because the question is asking me to solve the equation, I need to get x by itself. Sometimes we say isolate. So whenever we have to isolate x, one way of thinking about it is saying, so this is 7 times x, even though they don't show you the multiplication. And we want this to just be the letter x. So if you remember from Algebra 1 or even pre-algebra, hopefully you remember the rule that any number over itself is 1. So if you remember, like 2 over 2 equals 1. And negative 3 over negative 3 equals 1. And even if we didn't know it, even if it was just like a random variable, x over x equals 1, anything over its own self is going to equal 1. So if you look at how the answer is written, it's actually, there's like an invisible 1 here. You don't have to write the 1 whenever it's in front of the x. So we wish that this was, instead of 7x, we wish it was just 1x. So we're actually going to put this over 7, because that way it'll cancel out. It actually turns into a 1, and we have isolated x. Another way to think about it is just saying, okay, here I was multiplying by 7, now I'm dividing by 7. And whatever I do to the left side of the equation, I also have to do to the right. Now this is a coincidence that the answer is 1, and that was 1. It's just how it ended up working out. All right, for number 2, here's this if you needed to write it down again. So that was everything. Remembering when we're trying to move the entire term, we want to zero it out. That's why we did the opposite of addition, subtraction, which was addition. Here we wanted it to turn into the number 1, which is why we used division instead of multiplication. So over here, our like terms are 2 and 6. The 7 doesn't get to be considered a term that's a constant because it's in the same term with the n. So our constants are just 2 and 6. So because I want them to be on the same side of the equal sign over here, and I want this to zero out, I'm going to subtract 2 from that side. That's going to zero it out. And I'm also going to have to subtract 2 on that side. And then lastly, because I want to be able to get n by itself, I want to isolate n. I wish, instead of this being like a number which is really 1 over 7, 1/7, I want this to cancel to just the value of 1. So I know I'm going to need to put a 7 right there next to the n so that these two cancel. So when you put that 7 next to the n, you're actually multiplying by 7. So those cancel. And I can do the same thing on this side and multiply by 7. And I'll end up with n equals 28. All right, number 3 had some distributive property going on. At least that's how I look at it right away. So I would distribute the 3 to both terms. So that would give me 3x plus 6 equals 18. Then I need to move my constants to the right. So I'm going to subtract 6 from both sides. That zeroes this one out. And I get 3x equals 12. And then I want this x to just have a 1 in front of it instead of a 3. So I need to use that identity property of division, put that 3 underneath it, that becomes a 1, but I'm also going to have to divide this side by 3. So I end up getting that x equals 4. Now, there's actually another way you could do this if the problem is set up where there's only one number being multiplied by a parenthesis. This wouldn't work every time depending on what else is over here in the equation, but I did just want to show you the option. So option 2 for solving it, instead of starting out with that distributive property, you actually could have started out by getting this 3 to divide to the other side. So I could have actually divided it out by 3 on both sides. That would cancel this to a 1, and now I don't need these parentheses anymore because there's just a 1 on the outside. So, and I don't even need to write the 1, so I could just write x plus 2 equals 18 divided by 3, which is 6. And now I just need to move this positive 2 to the other side, so I'm going to zero it out by doing minus 2. And so I'm going to get that x is equal to 4, which was the same answer I got over here. But just so you can see another option. So like I said, that only works if the way you're solving it, it has only one number being multiplied by a parenthesis. It wouldn't work if there was like a 5 in front of the negative sign. So I usually still just do distributive property. Be careful with this distributive property because it is a negative 2. So negative 2 times 2 is negative 4. We'll keep the y there. Usually people get the first one right, but then they mess up on the second one. That's negative 2 times negative 5, which is positive 10. And then because I want to get the like terms over on the same side of the equation, I'm going to move that 10. I'm going to zero it out by doing minus 10. And then I end up with 30 minus 10, which is 20. And then here, this is actually negative 4 times y. So because these are combined with multiplication, you're not adding the 4 to the other side. That actually wouldn't move it to the other side if you added 4. Remember, you want the number in front of the y to just be the number 1. So I'm going to actually put negative 4 underneath itself. That way these two things cancel and they basically just turn into the number 1. And then if I have dividing by negative 4 on the left, I need to also divide by negative 4 on the right. So negative 4 over negative 4 will cancel and you'll just get y equals 20 over negative 4, which is negative 5. Remember, when you divide a positive number by a negative number, the answer will be negative. You could also use option 2 for this. You had negative 2, 2y minus 5 equals 30. So you could have divided everything by negative 2 if you wanted. $30 divided by negative 2 is negative 15. Then you could add 5 to both sides. And you would get to y equals negative 15 plus 5 is negative 10. And then you could divide both sides by 2. And you would still get x equals negative 5. So, you know, if you prefer to do it that way, you can, but it's not necessary. All right, now number 5 is the one that was tripping people up in class a little bit more, so let's talk about that. This one trips people up because there are variables on either side of the equal sign. So there's an n on that side and an n on that side, but we also have constants on both sides. So here's where it's different. Up here in this one, I was actually trying to separate the 3 and the x. I was trying to make it so that the x was isolated by itself. That's why I divided by 3, because I was trying to get x by itself. Right here, I can't get anything by itself until the like terms are together on one side of the equal sign. So again, just like this one, there were 2 different ways to solve it. There's actually going to be 2 different ways to solve number 5. So I'm going to show you both ways. Pardon me. So we need to get the 6 and the 6n and the 4n together on the same side. So some people like to always move the variables over to the left. But remember, you're moving the entire thing over to the left. So if I'm going to move the entire thing, I need to turn it into a 0 here. So if this is positive 6n, to turn it into a 0, I have to do negative 6n. Because 6n minus 6n is just 0. But if I did minus 6n here, I also have to do minus 6n over here. So 4n minus 6n is negative 2n. Now I want to get the constant terms together. So I want this 5 to be over with the 7. So I need to 0 it out here. So I'm going to do minus 5. I'm going to do it on the other side. And now my last step is to get n by itself and isolate it. So I'm going to divide both sides by negative 2. I want that negative 2 over negative 2 so that it reduces to a 1. And I'll put that over negative 2. So I'm going to end up getting n equals 2 divided by negative 2 is negative 1. So that's going to be my answer. Now, I said there were 2 different ways to do this. So let me write option 2 here. So what I like to say is that in algebra, there are positive people and there are left movers. Over here, I pretended I was a left mover. Left movers always like to take the variable and move it to the left. Typically, it's because that's how their teacher taught them to do it. But some people recognize, or their teacher taught them, especially in Algebra 1, when you're doing inequalities with the less than sign and the greater than sign, it's easier if the variable stays positive. So you'll notice when I subtracted 6x over here, 6n, I had to do 4 minus 6, which gave me a negative 2 with the n value. So what a positive person would do is they would notice that the 4 is smaller than the 6. So they always try to move the smaller number to the other side. So now remember, we're moving this entire term. So because we're moving the entire thing, we have to turn it into a 0. So 4n minus 4n is going to be 0. And then over here, we're going to do minus 4n. We can bring everything else down. But when we do 6 minus 4, now we have a positive number. And even though we end up getting a negative number in the next step, so we're going to move this 7 to be over there with the 5, but we're going to have to 0 it out here. So we're going to do negative 7. And we're still going to end up with the final last steps where we divide both sides. Here we're going to have negative 2 divided by positive 2. Here we had positive 2 divided by negative 2, but we still get negative 1. So it doesn't change your answer, it just changes kind of what the steps look like while you're doing it. So I would recommend don't try to do it both ways. I mean, unless you have extra time and you're trying to check your work. Just pick which one feels more natural to you. Do you feel more comfortable always knowing like, okay, I have to move the variables to the left? Or can you think mathematically enough to realize which number is smaller and that that's the one you need to move? So that's up to you. Over here for number 6, we've got a 5x and an x. So in a perfect world, we would combine like terms right here. So remember that's an invisible 1. So we've got 7x minus 4, and then we've got 5x minus 1x. So if we put those together, we get 4x, and then we can bring down plus 35. Now in this problem, the positive people and the left movers are gonna end up doing the same thing because you have to move it left to stay positive. So I wanna move this entire 4x so it can be with its like term, the 7x. Now because this is a positive 4x, I have to zero the whole thing out here. So I'm gonna have to subtract 4x. So that zeroes out. Now I'm gonna move my 4 to the other side. Now this is a negative 4. I need it to be 0 on this side, so I'm gonna do plus 4. So that zeroes out, and I get 3x equals 39. Let me just write it over here. And then because I wanna get x by itself, I'm just gonna divide both sides by 3, and I'll get that x is 13. Oh, sorry, couldn't see that part. All right, just 2 more on this one. For number 7, if you wanted to be a left mover, you would move this 9x to the left. So I would subtract 9x. So that zeroes out, and subtract 9x here. I always start by moving the x's. You could start by moving the other numbers, by moving the constants, but I start with the x's. So negative 5 minus 9 is negative 14. Then I can move the 71 to the other side. Now don't forget, sometimes when the number is the very first number, it's not gonna have a plus sign in front of it to show that it's positive because it's the first number. You do have to remember to subtract it because remember, it helps to remember you're trying to make this turn into a 0. So if you can remember that, it might help you to not forget that negative or switching the sign at least. So over here, minus 71. So negative 14x. Negative 13 minus 71 is like you owe someone $13 and then now you also owe them $71. So in total, you owe them $84. Now, this is the part where we're not trying to zero it out. We're not trying to turn it into a 0 because we're not moving the whole term to the other side. We're only moving the negative 14. And that's just because we don't want it to be a negative 14. If we want to solve for x, we just want it to just be a 1. So we're going to put this over negative 14 because negative 14 over negative 14 is 1. You know, that's the point of doing that. So over here, I'll divide by negative 14. Now you do have to remember that a negative divided by a negative is a positive, and 84 divided by 14 is 6. So that's why we get 6 for x. Now option 2, if you are a positive person, 71 minus 5x equals 9x minus 13. So this is option 2. So option 2 is instead of moving that 9 over to the left, you would move this negative 5 over to the right because you would be thinking, okay, the smaller of the numbers is the negative 5, so I'm going to move it to be on the other side. So I'm going to add 5x, that way it zeroes out. 9 plus 5 is 14. Now when we move the 13, it's going to be adding 13, so this becomes 0. And then we're going to get our final answer just by dividing both sides by 14. Pardon me. So x still equals 6. There's nothing that changed. But it's just in the opposite order. So here we said x equals 6. Here we got 6 equals x. To actually switch those, we use something called the symmetric property. It just means that x equals 6 can switch and become 6 equals x. Or we wanted x equals 6 because the answer was written in that form. So 6 equals x, we would use the symmetric property to say it's the same thing as this. Okay, last one. Number 8 is talking about the same problem. It's actually even easier because our like terms are on the same, well, these two like terms are on the same side of the equal sign. This like term needs to be moved over, but I would just combine these two. So 8y minus 5y is 3y. Now I need to get the 2 over there with the 16. So it zeroes out here. And then I want to get y by itself. So I'm going to put the 3 over 3. So it becomes a 1. And then the 14 over 3. And what we can actually do here is just write the answer as 14 over 3. The question didn't tell us what to round to. If you put that in your calculator, let's see if the glare is too bad on this one. Oh no, that's great. So if I put 14 divided by 3 equals, you can see you get this repeating decimal. It actually doesn't end in a 7. It keeps going with a 6. The calculator just rounded for you. The problem doesn't tell you to round. So you're not actually allowed to write anything with this 7 because this is a round, like that's a rounded number. If you were going to write it, you could write it as 4.6 repeating. You could also write it as a mixed number. So 3 goes into 14 4 times, and then there's 2 left over. So we would say that it's 4 2/3. If your teacher told you to round, so if you read the directions and it said round to the nearest 10th, then you could write 4.7. If it said round to the nearest 100th, you would write 4.67. But if it doesn't say to round, you're not allowed to. So the best answer ever is the improper fraction. So this is the answer we like the most. Technically, I would still accept these two answers because they are accurate. I would not accept an answer that was rounded, like with a 7 in it, unless the question specifically said in the directions that you could round and they told you what to round to. All right, hopefully that's somewhat helpful, and I hope you have a wonderful day.